Hello everyone, today let's solve the problem number 70, climbing stairs. So what the question states here, you are climbing a staircase with n steps. So you can clearly see here, this is nothing but n steps. So we are climbing a staircase with n steps. Each time we can either take one step or two steps. So each time we can either take one step or two steps, right? We cannot take more than two steps. Either we can take one step or two steps to climb the stairs. This we have to keep in mind. What is our main task here? Our main task is to find the number of distinct ways to reach the top. So the top here they have given 2, n equals 2 means 2. So here output they have given here as there are two distinct ways to climb the top. One is either we can take one step at a time, one step plus one step we will reach the top, nothing but the second staircase, this one second staircase, right? Or either we can take two steps at a time to reach this one second staircase. So these are the two distinct ways to climb to the top, right? So that's what we have to return as output. So how many distinct ways are there to climb the top? That's what we have to return in case of output. In this case it is 2. When n is 3, we can go with one step at a time, one step plus one step plus one step, we will reach 3. Or one step plus two step, right? That also we can do, we will reach third staircase. Or we can go two step plus one step, right? Two steps plus one step. So these are the three distinct ways to climb to the top. So the output that we have to return here in this case is 3. So I hope the question is clear. What we have to find here, we have to find the number of distinct ways to reach the top, right? So how can we articulate this one in the form of code? Let's see the same thing. Initially let's go with the approach, then followed by the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, as usual, let's discuss the up. So here these are the same examples that they have given in the question, right? So n equals 2, there are two distinct ways, nothing but one step plus one step and two steps at a time. For n equals 3, one step we can go one step at a time and it will be one step plus one step plus one step, or we can go with one step plus two steps or two steps plus one step, right? We know this one, right? Let's hop into the step 1. So here you can observe one thing from these two examples. So first example and the second example that we have considered here, right? So you can observe one thing, the pattern is similar to the Fibonacci sequence, right? So nothing but here this one you can clearly observe whatever I have written here, ways of n equals ways of n minus 1 plus ways of n minus 2. That means here from n minus 1 we can take one step, or from n minus 2 we can take two steps at a time, right? Either from n minus 1 either we can take one step, or from n minus 2 we can take two steps. I hope this is clear, right? So I hope this is fine. Let's move on to the final step. So we will be making use of dynamic programming or the DP. Why we'll be making use of DP here? We have to store the intermediate results, right? So for that one, and also every time we don't have to calculate. So to avoid the redundant calculations and to store the intermediate results, we will be making use of the DP. So we'll be going with the DP or the dynamic programming just to store the intermediate results and to avoid the redundant calculations. Again and again we don't have to calculate. So let's make use of the DP. So next step is let's discuss the edge cases one by one. I hope the approach is completely clear. This is the approach that we will be going with. Next, let's discuss the edge cases one by. So here the first edge case, let's go with when n equals 1 here. When n equals 1, the output will be 1 here. Why? Because only single step, right? So there is only one way, nothing but we will take one step at a time. So second edge case, let's consider here when n equals 2 here, right? There are two ways. Either we can take one step plus one step, or directly we can just consider two steps. So the third edge case we'll go with here is when n equals 3. So when n equals 3, there are three ways, nothing but one step plus one step plus one step, or this one two step plus one step, or one step plus two steps, right? So this is fine. Next, let's go with the fourth step fourth edge case when n equals 4 here. So here in this case, there are 5 different ways here. So when n equals 4, this will be one step plus one step plus one step plus one step. This is fine. So this will be one step plus one step plus 2 steps. This is also fine. And one step plus 2 steps plus 1 step. This is fine. This is third way. This either we can go with 2 steps plus 1 step plus 1 step. This is also fine. Or we can just go with 2 steps plus 2 steps. So these are the 5 ways we have when to reach the top, nothing but to reach fourth staircase. So 5, let's go with n equals 5. So just I don't want to write this one again. You have the idea. Just follow this one, or just it follows the Fibonacci, right? So I hope this is clear. These are the edge cases that we need to consider. So I hope this is completely clear, right? So let's start writing the code now. So let's start writing the code here. The base case will be for the when we have 0 steps or when we have 1 step. There is only one way to climb 0 or 1 step. So let's write the same thing here. dp equals 1 comma 1. So we already know that by the approach that we are going with the dp right here. So let's start from the step 2 and build up. So when I say let's start from the step 2, I'll just start from here. I equals to I less than or equal to n. Let's increment the I here. So I hope this is clear. Next step, the current ways equals to the sum of previous 2, right? So this we had discussed in the approach 2. This is similar to the Fibonacci, right? Similar to the Fibonacci sequence. So current ways equals sum of the previous 2, right? So I can articulate that one in the form of code in this way. Iterated value of the dp of I minus 1 plus dp of I minus 2. Nothing but here current ways is equal to sum of previous 2. That's what we have written here. The next step is we have to return the final result for n steps, whatever the n steps they have given here. And this is n equals 2. We have to return this one, right? Final results for the n. This will be dp of n in this case. So let me do one thing. Let me format the code once and let me hit the run button. So here we are getting wrong answer. Why? Let's check what is wrong. So here in the line number 8, you can clearly see I forgot to make use of the return keyword here. So that is the reason we are getting wrong answer. Let me format this one once and let me hit the run button. So this is fine. Now you can clearly see the sample test cases are getting accepted here, right? So I hope this is completely clear. So the approach that we went with here is dynamic programming. This is fine. So what will be the time complexity, overall time complexity and the space complexity here? The overall time complexity would be big O of n and the overall space complexity would be big O of n as well, right? So as we went with the dynamic programming, right? So I hope, just give me a second here. Didn't I submit? Basically I forgot to submit, I think. So let me submit this one. I hope this works. Let's see. Yeah, we have already discussed this works, right? So the code works absolutely fine here. So we have already discussed the time complexity and the space complexity as well. I hope the solution that we have written is completely clear. For now, this is it. Thanks for watching, guys.